Okay, we are going to try to solve the same quadratic equation with all the different methods that we've talked about in class. So, solve by factoring. First thing you want to do, I'm going to take my equation here. I have 3x squared minus 12x plus 9 equals 0. Anytime you're trying to factor, take out any greatest common factor. I'm going to write GCF, greatest common factor. What I'm going to notice, all those terms are divisible by 3. So before I even start the problem, we're going to divide everything by 3. X squared minus 4x plus 3 equals 0. Now, from factoring, what I want to do, make sure it's set equal to 0. I need, for my factors here, don't have a number in front of the x squared, so we don't have a Berry method or anything like that. So I'm going to multiply the first number, which would just be 1, times the last number. So I need two numbers, 1 times 3, multiply to get me 3, add to get me the number in the middle, or the b value, which is negative 4. The two numbers that'll fit both of those requirements are going to be negative 3 and negative 1. If we were to FOIL that back out, that would give us the quadratic. The reason we're factoring it is because in that format, I can see my two answers are 3 and 1. Okay, now I'm going to solve the same equation by graphing. Now, this is totally your choice. What I want to do is graph 3x squared minus 12x plus 9. Now, I could, since those are all divisible by 3, I could also graph just x squared minus 4x plus 3. Both of those will cross the x-axis in the same place. So whichever one you want to graph, they'll both give you the same answer. I'm going to go ahead and graph the equation we were given. So what I want to do to find the vertex is the opposite of b, so plus 12 over 2a, 2 times 3, it's going to give you 12 over 6, which is 2. And then if I want to figure out my y-coordinate of the vertex, I just plug that in. So 3 times 2 squared minus 12 times 2 plus 9. And you can type that right into your calculator if you want to. This first term, 2 squared is 4 times 3 is 12. It's going to be minus 24 plus 9. Combine your like terms there. This is going to be negative 12 plus 9, which is negative 3. So my vertex, 2, negative 3. And my pattern. Now, that's affected by your a value. So my 1, 3, 5 is going to become 3, 9, 15, which is not going to fit on the graph. But from there, I'm just going to go over 1, up 3. And I could go over 1, up 9. It would just be right above the graph. But what I'm looking for here for my zeros are what are the x values that would set me to a y value of 0. The place where that happens is where you cross the x-axis. And so for this question, 1 and 3, which matches what we had here. Now, if you had graphed x squared minus 4x plus 3, your graph would have looked a little bit different than mine. It would have been a little bit wider, but it should still cross at those same values. Okay. Now, completing the square. So, completing the square. Here we had 3x squared minus 12x plus 9 equals 0. For completing the square, the a value has to be 1 before you start. So, for this question, I cannot have a 3 in front of my x squared. So, I would divide everything by 3, which I can do on both sides, and we're going to end up with our x squared minus 4x plus 3 equals 0. Now, you want your x squared and your x term on one side, and you want your constant on the other side. So what I mean by that, I'm just going to come over to my equation. I'm just going to move the 3 because I want my squared term, and I'm going to leave myself a little space here so I can complete the square. And I'm going to add a number, and whatever number I add, if I do something to one side, I have to do it to the other side. So here's me putting my squared term and my x term, so my quadratic and my linear terms on one side. Just move any numbers to the other side. Okay, so to complete the square, we're just going to take the b value divided by 2 squared. For the problem we're working with here, be negative 4 divided by 2 squared, negative 2 squared, and that would be 4. So I'm going to add 4 to both sides of that equation because that keeps my equation balanced. The entire purpose of completing the square is I'm creating a situation where my two factors are exactly the same. So this factors of 4 that add up to negative 4 would be x minus 2 times x minus 2, or the whole purpose of doing this, I can get x minus 2 squared. When they're each the same, I can squish it together. The reason we're doing this is then I can cancel those parentheses out by taking the square root. So I have x minus 2, and square root of 1 is actually 1. I got to move that 2 to the other side, so we'd have to add it. So x equals 2 plus or minus 1. Well, 2 plus 1 is 3. 2 minus 1 is 1. And again, I'm getting these same answers. That's what I'm trying to show you guys, that all these different methods yield the same answer. 1 and 3 are still the answers, just like they were up where we did the graph and where we did the factoring. Okay, now the final method to show that these are all the same quadratic formula. If you want to go ahead and use the original problem, we don't have to take a greatest common factor out in front. We don't have to divide everything by 3. We can, if you want to do that, or you can just go ahead and work with this problem. The only time you have to get rid of the number in front of the x squared, you do need to do that if you're doing factoring, and you do need to do that if you are completing the square. For graphing or for quadratic formula, though, you can just use the quadratic as it's presented to you. Okay, so for quadratic formula, my a value would be 3, b would be negative 12, and c would be 9. Okay, so I'm just going to plug it in over here. Opposite of b would actually turn into positive 12, plus or minus square root 12 squared minus 4 times 3 times 9, all over 2 times the a value, so 2 times 3. 12 plus or minus, this is going to be 144 minus, forgive me, I got to grab a calculator here. So 4 times 3 times 9 is going to end up giving us 108. So 144 minus 108, everything over 6. And if I do 144 minus 108, that's actually just going to give us 36 under the square root. So here's what we got going on, because that's a perfect square. Plus or minus 6 over 6. Okay, now I know this is a little weird. Each of these terms are divisible by 6, so this would turn into 2 plus or minus 1 over 1. Well, 2 plus 1 divided by 1 is 3, and 2 minus 1 divided by 1 is 1 again. And so you can see every single one of these methods yielded the same answer. The only time you need to take, if you've got a number in front, sorry, I'm pointing at the wrong thing, you've got a number in front of the x squared, the only time you need to try to get rid of that if you can is if you're factoring and everything's divisible by that number, and then also definitely if you're completing the square before you start the problem, you have to divide. For quadratic formula or for graphing, you do not need to do that.